All right, welcome to CSE 223. This is our Advanced Data Structures Object-Oriented Programming course, the third and final course in the 224, 22, 23 sequence. So this first video is a bit of a warm-up. A lot of people won't have watched this before the first class, so we're going to watch this in the first class together and then work on some of the problems from the first problem set. And it's really just kind of getting our feet wet with some Java, exploring the Java command and a few things like that. A lot of the exercises we're going to do this quarter, we want to do on the Linux server. So if you've done 224, 22 this year, you have an account. If you don't have an account, come and talk to me. We'll get you set up right away. I already have an account, and I've got a shortcut for Nick at linuxengrcs.com. I've got a SSH handshake set up, so I can just log in right away without having to type a password. You can do that. We go over it in 224. If you want to set that up, let me know. We'll set you up also. One suggestion I have, and this isn't the top of the problem set, is when you're working through this course and these problem sets, I suggest trying to be very organized. A lot of the problems will reuse problems that you worked on earlier, and you don't want to keep having to reinvent the wheel, keep developing code that you've already developed. So I really suggest pick an organization scheme, and one possibility would be to make a top level 223 directory. And then within there, I don't know, you can do something like class 1. This is the class we're in right now. And so, I'm in a nice little subdirectory, and then in 2 days when I come back for class 2, I'll make a CSE 223 class 2, and I'll put all my work in there. And, the problems are set up with, problem numbers on them. And some of them you're just, trying things or reusing code. Some of them you're actually writing code. So, you can call your problems whatever you choose. Some of the problems tell you, name this p3.java and so on. But at least, make yourself a separate directory for each class and do your work in there. One of the first things we can do is just type the word Java, right? And what does that do? Well, it gives us a bunch of back talk, right? It's giving a usage message, so it didn't like us just typing the word Java, but it's showing us what we can do. We can say Java, we can put in some options, we can put in something called a main class and then optional arguments, or we can say java-jar in a jar file or a module, and so on. But basically, Java is the command we use to run the code inside a Java class, effectively to run our program. And there's a sample program. It's mentioned in the problem set under /user/local/bin. There's a class called hello. And so if I say java-cp/user/local/bin hello without the .class on the end, if I run that, followed by, so I have to follow the instructions I wrote. So -cp says where this file is located, and hello is the name of the file that I want to execute. So if I do that, it gives me a hello world, right? It says hello. So Java is the command for executing a Java program, right? And it's a little more complicated than that, but for now we can think of it as, this is a Java program. And this works because if I look at, let me switch over to this directory for a minute. If I look in here, there's a file called hello.class. I made this last month. It's pretty small, it's 417 bytes. And if I try to look inside it, it's not really human readable. It's got some words. It's got the words hello there, which we saw, but it's also got all of these control characters. If I do an XXD to look at it in hex, we can see it's got a bunch of whatever these things are. They're basically like opcodes. But when I use the Java command, it does something, right? It actually prints out a message. So let's go back to our work directory and let's make a sample program. So test1.java. And we're not going to worry yet about what these things mean. We'll dig into this later, but for now we're just going to write some code and see what it does. And then in the next class we'll start taking apart this program and seeing what each of the different pieces do. So I'm going to start with class test1. And I'm calling my class test1 because my file is called test1.java. And now I'm going to type something that you're going to type over and over and over again this quarter. I'm going to write public static void main parentheses string bracket bracket args close paren curly bracket. And then this is another thing you're going to type over and over again. System.out.println. This is a test. \n, which we know from the C language. Closing curly bracket, another closing curly bracket. All right. So at a high level view, what is this thing doing? Basically, I'm defining a class. A class is like a C structure, but it's a structure that can contain data as well as code. So this structure contains a function. It's a function called main, and what that function does is this thing, which is like a printf statement. It prints out a message that says this is a test. So I've got this file called test1.java. I need to compile it, right? If I just try to run it, if I say java test1, it's going to say it can't find a test1. This is a source program, right? We know that because I can cat it and, read the contents. So that's source code. We need to compile it. And the way we compile it is by saying javac. That's like GCC for Java. So javac test1.java. And now if I look in my directory, I've got a new file, test1.class. That's like an executable file. It's actually more like an object, but for now we'll think of it as an executable. So test1.java was the program that I wrote. Test1.class is the program that was created by the compiler. And again, if I look at this inside VI, it's not really human readable. But I can run this now by saying java test1, and it executes my program, and it says this is a test. All right, so that's a very, very simple hello world, basically, for Java. And the two takeaways from here are the command javac, which we use to compile a .java file into an executable, and then Java, which we use for running an executable. And if you just say javac, you get a help message which shows you the different ways you can use it. And then same for Java, that shows you the different options and so on. So we're going to look a little bit at what this is doing in terms of what is a source file, what is an object file, and that will do it for class 1, right? We're just going to get our feet wet, and then we'll go on to the next class where we're going to start understanding what all of this stuff means, this class statement and this public static void main and this and so on. So one of the ideas of Java is portability. Being able to write Java code and have it run on different platforms. And it can run on desktops and laptops, but it can also run on devices. When Java was being developed, there was a Java ring you could buy that would actually run Java code. You can run it on Raspberry Pis. You can run it on lots of different platforms. And you can write a C program and run it on different platforms, but you have to compile it on whichever machine you want to run it on. And if I have C code and I compile it for my Intel processor-based laptop, and then I take that executable program and I put it on a Raspberry Pi, it will not run, right? Because the machine code for an Intel processor is different from the machine code for the processor in a Raspberry Pi. But with Java, it does not compile your program into actual machine code. It compiles it into virtual code. And that virtual code runs on a virtual machine called the Java Virtual Machine, or JVM. And the Java command, when I say Java and I put in the name of a class file, It's saying start one of these virtual machines, an imaginary CPU that's being, emulated inside my actual CPU, and is reading what's effectively machine code from this test1.class file, interpreting it, and then executing it as if it were running on hardware. So all of our Java code runs in this virtual machine, the JVM, Java Virtual Machine. And there's a few advantages to that. The first is portability, because if I have the same a JVM on a different machine that understands the same virtual code, what we call bytecode, my class file will run on a different platform. Another advantage of having a virtual machine is security, right? We can sort of wrap all of the execution context of this program inside what's happening in this virtual machine. So it's like in 224, if you use VirtualBox, you can, delete all your files on your hard drive in the virtual machine, and it doesn't affect anything on your actual machine. So there's the potential for sandboxing our code when it runs in a JVM, a Java Virtual Machine. So Java C compiles our source file, test1.java, into something like machine code. It's called bytecode. And then Java, followed by the name of a class file, says, hey, start a virtual machine, read the bytecode from this file.class, and execute it. And so that's basically how our code gets executed. And in C, when you write a program, you have to call your main program main, right? So the same thing happens in Java. We have to have a main program, and it's got to be called main, but it's also got to have these other tags. It's got to say public static void main, and the argument list has to be an array of strings. This is how we specify an array of strings. That's the argument list to it. And if we have a main program like this, and then we try to run the compiled code, it will run. Now, if I change the name of this, if I call this my main, I can still compile it, right? That works fine. But when I try to run it, it'll say, hey, I didn't find a program named, a function named main, right? So your main program has got to be called main. My main is perfectly fine, but it's not the main program, and so it won't run. It won't run that as a main program. But if I call it main, then it will go ahead and execute it. All right. So so you want to work on the problem set today, and basically get onto the server, go through these exercises. There's a sample program for you to type in. Take a look at the files that are created when you say Java C, and so on and so forth, and then try executing your program. And you don't have to just print out this message. You can try some other print messages and so on. I'll warn you up front, Java is a lot like C. So if you want, you can start to experiment and do things like this. Right, this is how we would try to write a for loop in C. I'd say for integer I equals 0, I less than 10, I plus plus, and I put my print statement inside there. And if I do that, it will do exactly what we expect in Java. Right, it will go ahead and it will run that print statement inside a loop. So you can do some of the things that you know how to do in C. And that's useful. That will get us up to speed more quickly knowing C. But very soon we're going to deviate from writing C code. We're going to actually start writing Java code. And it's important when we do this, remember that we're writing Java, right? Don't just try to rewrite C code in Java. You can do that. But Java has this idea of objects and being object-oriented. That's what the next lecture is going to get into. And we really want to take advantage of that. So it's good to leverage our understanding of C to do things in Java, but we definitely want to go beyond what we already know how to do in C and start thinking about objects. So that'll be the focus of class 2.